Hi, I'm Cynthia Ayesha Bipanganti. I'm Crystal Jane Everclia. I'm Ramina Yuso.
And Juvenile Sitan.
Clear the Conic sections!
Hi, I am Andrian Padilla and I am the video editor in shop.
Every day and everything that we always see is connected to conic section. Now, we are going to talk about conic sections, like what are the types of these and what are the things that are related to conic sections. We will the brief history of conic section, including the mathematicians. Menaechmus, Greek to 380 BC to 320 BC, was an ancient Greek mathematician and geometer born in Alopeconissus in the Thracian Chersonese, who was known for his friendship with the renowned philosopher Plato and for his apparent discovery of conic sections and his solution to the then long-standing problem of doubling the cube using the parabola and hyperbola. Alexander the Great was an ancient Macedonian ruler and one of history's greatest military minds who was king of Macedonia and Persia, established the largest empire the ancient world had ever seen. They were conceived in an attempt to solve the three famous problems of trisecting the angle, duplicating the cube, and squaring the circle. The conics were first defined as the intersection of a right circular cone of varying vertex angle, a plane perpendicular to an element of the cone. Apollonius to 262 BC to 190 BC, known as the Great Geometer, consolidated and extended previous results of conics into a monograph, Conic Sections, consisting of 8 books with 487 propositions. Quote from Maurice Line: as an achievement, Apollonius' conic section is so monumental that it practically closed the subject to later thinkers, at least from the purely geometrical standpoint. Book 8 of conic section is lost to us. Apollonius was the first to base the theory of all three conics on sections of one circular cone, right or oblique. He is also the one to give the name ellipse, parabola, and hyperbola. In Renaissance, Kepler's law of planetary motion, Descartes and Fermat's coordinate geometry, and the beginning of projective geometry started by Desargues, Lahaire, Pascal pushed conics to a high level. Many later mathematicians have also made contributions to conics, especially in the development of projective geometry where conics are fundamental. In this video tutorial, you will learn the conic section. So that is the vertex in the conic section where the fixed point is. Then, the line that rotates the vertex is the generator, and the line that fixes is called the axis. Then, the conic section have a circular base. Then, the perimeter of a circular base is called the directrix. Circle. A circle is formed when the plane is parallel to the base of the cone. Its intersection with the cone is therefore a set of points equidistant from a common point, the central axis of the cone, which meets the definition of a circle. All circles have certain features: a center point, a radius, which the distance from any point on the circle to the center point. The generate form of the circle occurs when the plane only intersects the very tip of the cone. This is a single point intersection, or equivalently, a circle of zero of radius. The standard form of circle is the quantity of x minus h squared plus the quantity of y minus a squared is equals to r squared. While on the other hand, the general form of circle is x squared plus y squared plus cx plus dy plus e is equals to 0. The second conic section is the ellipse. An ellipse is the set of all points for which the sum of the distances from two fixed points, the foci, is constant. In the case of an ellipse, there are two foci and the two directrices, when the plane's angle relative to the cone is between the outside surface of the cone and the bases of the cone. The resulting intersection is an ellipse. The definition of an ellipse includes being parallel to the base of the cone as well. So all circles are a special case of the ellipse. Ellipses have these features: a major axis, which is the longest width across the ellipse; a minor axis, which is the shortest width across the ellipse. In finding the standard form of any ellipse, we should first try to figure out if what we are looking is vertical or horizontal. If the major axis is horizontal, the formula will be quantity of x minus h squared over a squared plus quantity of y minus k squared over b squared is equals to 1. If the major axis is vertical, we need to use quantity of x minus h squared over b squared plus quantity of y minus k squared over a squared is equals to 1, while the general form of ellipse is ax squared plus bxy plus cy squared plus dx plus ey plus f is equals to 0. The third conic section is the parabola. A parabola is the set of all points whose distance from a fixed point, called the focus, is equal to the distance from a fixed line, called the directrix. The point halfway between the focus and the directrix is called the vertex of the parabola. The standard form of parabola is quantity of x minus h squared is equals to 4c times the quantity of y minus k, while the general form of parabola is ax squared plus by squared plus cx plus dy plus e is equals to 0, where either a or b is 0. And the last conic section is the hyperbola. A hyperbola is the set of all points where the difference between their distances from two fixed points, the foci, is constant. In the case of hyperbola, there are two foci and two directrices. Hyperbolas also have two asymptotes. A hyperbola is formed when the plane is parallel to the cone's central axis, meaning it intersects both parts of the double cone. The standard form, if it is a horizontal hyperbola, is quantity of x minus h squared over a squared minus the quantity of y minus k squared over b squared is equals to 1. While the standard form, if it is a vertical parabola, is the quantity of y minus k squared over a squared minus quantity of x minus h squared over b squared is equals to 1. While on the other hand, the general form of hyperbola is ax squared plus bx squared plus cx plus dy plus e is equals to 0. The first scientific application or real-life example of a circle is the ball of the basketball game. The second scientific application or real-life example of a circle is the wheel of we so-called kalesa. These two real-life examples shows the shape of a circle because if we put a point in the center of these objects and measure the distance between the center point to a certain locus point around this object, resulting to having the same measure from each center to that locus point. The first scientific application or real-life example of an ellipse is the eyes of a human. The second scientific application or real-life example of an ellipse is the lip. The shown pictures are examples of ellipse. Imaginally, put a point at the center of these two objects. So, if we try to look at it in the major axis, the measurement from the center point going straight to the locus point of these two objects have the same measurement to its other side, just like how it goes to the minor axis. The first scientific application or real-life example of a hyperbola is the curved lines in the ball being used in the basketball game. The second scientific application or real-life example of a hyperbola is the curve of a Coca-Cola body or a curve of the Coca-Cola liter. These two objects are hyperbola. Seeing these pictures, hyperbola has two disconnected branches that look similar to parabolas like these two objects also. The first scientific application or real-life example of a parabola is the flower. The second scientific application or real-life example of a parabola is the trajectory of the ball being shot. A parabola, because these two scientific application is an example of parabola, it shows that this object shapes like a half of circle. Take note that the locus points of the parabola are equidistant to the fixed point or parabola's center like these two objects.